Okay, it's time for my all-time favorite trig identity proof. Secant squared times cosecant squared equals secant squared plus cosecant squared. Now, that looks pretty bizarre to me. Why would two things multiplied by each other be equal to those same two things added to each other? It's usually not the case, but in this case, it happens to be true. So try it out. Hit pause on the video. Please try this on your own. Come back, and I'll show you how to do it. Okay, so again, notice that we only have x's in this problem, so we don't have to worry about any of those double angle identities. We do have a lot of squares in this problem, so we might have to be using a Pythagorean identity at some point. The only place where we'd be able to use that now would be on the right-hand side. You'll notice there are two terms added to each other, and they're both squared. Now you could look at your list, and unfortunately it's not going to help you too much because there aren't any identities that have both a secant and a cosecant in there. So what I'm going to do is I'm going to try to just write this thing in terms of sines and cosines, and hopefully something will happen. So secant, you know, is 1 over cosine. Cosecant, you know, is 1 over sine. Same is true for the right-hand side. And there are a couple ways to do this problem from here. The first thing that I would notice would be that you have a lot of denominators. And I don't typically like denominators, so I would want to get rid of them. So what I would probably do right off the bat is I would multiply everything, both sides of the equation, every single term, by sine squared x cosine squared x. If you do that, you'll get rid of all of your denominators. And I'll sort of write this out a little bit more explicitly. So we have 1 over cosine squared x times 1 over sine squared x. And we're going to multiply that by sine squared x cosine squared x. Everything is multiplied in that term, so we're okay in doing that. This 1 over cosine squared x term, that's a term in itself, so we're going to multiply that by sine squared times cosine squared. The last term, we're doing the same thing. 1 over sine squared is going to be multiplied by sine squared and cosine squared. Hopefully you can see that part. Okay, so the whole purpose of doing this was to clear out all of our denominators. You'll notice that the cosine cancels with the cosine, the sine cancels with the sine. Everything is multiplied in that term, so we can do that. In this term here, everything is multiplied, so we can cancel that cosine squared with that cosine squared. In this last term, we can cancel the sine squared and the sine squared. Now, everything canceled from our left-hand side, and when that happens, we end up with a 1. What we're left with on the right-hand side is a sine squared plus a cosine squared. Oh my gosh, what just happened? We got 1 equals sine squared plus cosine squared. That's our fundamental trig identity, so we know that that's true. Let's try this one other way. Now I'm going to start with the same step. I'm going to write everything in terms of sines and cosines. By the way, if you've stuck with me for this long through these videos, I really appreciate it. And to reward you, the secret word is green sticky notes. Look for it on your next test. Green sticky notes is the secret word. Green sticky notes. Don't tell anybody. Don't spread the word. This is our little secret. Green sticky notes, the secret word. Okay, so what you might think of doing, you might be hardwired to find a common denominator on the right-hand side, and that is perfectly fine. Now, to find a common denominator on the right-hand side, I'm just going to copy down the left side. To find a common denominator over here, what we're going to have to do is we're going to have to multiply the cosine term by a sine squared over sine squared. Then we're going to have to multiply the 1 over sine squared term by cosine squared over cosine squared. That is perfectly fine. This is great. We haven't done any illegal algebra. We're moving our pencils, so this is good. We're going in the right direction. So we have a common denominator now of cosine squared times sine squared. Coincidentally enough, that's what we have on the left-hand side as well. If we multiply straight across our two fractions on the left-hand side, we just get 1 over cosine squared times sine squared. If we multiply our fractions straight across on this first term, we get a sine squared in the numerator, a cosine squared, and a sine squared in the denominator. For this right term, we get a cosine squared over sine squared times cosine squared. Now you notice that all those denominators are the same. Sine squared times cosine squared is the same as cosine squared times sine squared. So we can combine our right-hand side numerators. And it happened again. You'll notice that these two things are exactly equal because the numerators and the denominators are the same. Sine squared x plus cosine squared x is equal to 1. We use our Pythagorean identity, our fundamental trig identity, to prove that identity using two different methods. Pick the one that you like and do it that way. Good job. Thanks for watching the videos. I'm going to post a few PDFs here as well on the website with a few more identity proofs. And I'll see you all in class next time.